Find the volume of the described solid. The base of S is a circular disk with radius r. Parallel cross-sections perpendicular to the base are squares. So, first thing is first, we know that this is, when we graph this, what we have is this represents radius r. And recall that the circle has a formula of x squared plus y squared equals r squared. So this is the base. So let's take a look at this in a three-dimensional situation. So here is our circular section, okay? And so you can see here that we have a radius here, and then also a radius here. So therefore, there's the radius. Now it's telling us that its parallel cross sections are perpendicular to the base are squares. So let's go ahead and identify what that cross section looks like with the squares. So here we have this cross section. Let's go ahead and change that. So now we're making a cross section that's perpendicular to the base, which are squares. So what we're going to do is we're just going to sort of create a square here that connects one piece of that circle or the circular section to the other, right? So that should come all the way to the edge of the circle. So there's a couple things that we need to be careful of, and I'm going to go ahead and just redraw this so that we know it goes the whole way. So just let me go from here to here, and then we're going to draw our square. Okay, now remember the square. Okay, now the thing that we need to sort of make sure that we notice, the fact is that at this square, right, there's going to be this base times 2. And the reason why I say that is because you can see here from this x-axis, it's now going to that circular base that's there. Okay, now if we take a look at that, so we notice that from here to the center of that circle is the radius. We know that this represents the x and this represents the y. So that tells us that we're using this circular disk, which is x squared plus y squared equals r squared. So because it is perpendicular to the base, that means we're rotating it, in this case, around the x-axis. So this has to be in terms of x. So what we're going to first do is take this formula for the circular section, which is the function x squared plus y squared equals r squared, and then we're going to solve for y so we can put this in terms of x. So we're going to get y squared, which is equal to r squared minus x squared. Then we're going to take the square root of both sides, which would give us plus or minus the square root of r squared minus x squared. But we're only going to focus for the positive part of that, so we're going to eliminate the negative part. So we're just going to look at the function y equals the square root of r squared minus x squared. Okay? So what that tells us is that this square is now going to have this base, but there's two of them because there's one here and then there's another one there. So basically what it's telling us is that the base of this is going to be 2, since there's two of them, times the square root of r squared minus x squared. And remember that since it's a square, that means all sides are equal. So this side is also 2 times r squared minus x squared, and so on. So the next step we're going to do is put in the area in terms of x of s squared. Well, what do we know that side is? Well, we know that that side is 2 times the square root of r squared minus x squared. So now if we simplify that by squaring it, then we're going to get the following. 4 times r squared minus x squared. Okay, so now let's go ahead and find the volume. Okay, so in order to find the volume, we know it's going to equal a lower bound to an upper bound of a of x dx. So what is the lower bound and the upper bound? Well, if you notice here, it's in terms of x. So that means that you have this point here, which is r0. And then over here is negative r0. So therefore, we're going from negative r to r. But since we would like to then go from 0 to r, and because this is symmetric, we can then just multiply this by 2. Because that means this side is going to equal to that side. So now we're going to put in our function, a of x, which is 4 times r squared minus x squared. So that means we're going to take 4 now and multiply that by 2, and then we have r squared minus x squared dx. Okay, so now we're just going to take the antiderivative. So we know 4 times 2 is going to give us 8. We're going to go and then find the antiderivative. So the antiderivative of r squared is going to be r squared times x, since r squared is a constant. And then this is going to be minus 1/3 x cubed, which is going from 0 to r. Okay, now we're going to go ahead and evaluate this. So we have 8 times, well, this becomes r squared times r minus 1/3 times r cubed minus r squared times 0 minus 1/3 times 0 cubed. Well, we know that this becomes 0, and then we get the following. We get 8 times 1r cubed minus 1/3 r cubed. We know that this 1 is the same thing as 3 over 3. So therefore, this becomes 8 times 2/3 r cubed. And so 8 times 2 is going to give us 16. So therefore, this becomes 16 over 3 r cubed. And therefore, that is the volume of this question.